Okay, so this is angle measure in degrees and radians. You're all used to working with degrees. Okay, if I say picture a 30-degree angle, you got an idea what that looks like. If I say picture a 180-degree angle, you've got an idea what that looks like. If I say picture an angle that's pi over 4 radians, or an angle that's pi over 2 radians, or an angle that's 2 pi radians, right now, that's probably mush, right? Okay, so today, it's just like working in inches and working in centimeters, okay? We're going to work with a different measuring system, okay? By the time we get done with the trig, you're going to be thinking in radians, okay? Not just in degrees, okay? Okay, so one thing we covered was 1 revolution all the way around. And if we go 1 revolution counterclockwise, okay, counterclockwise is going up against the clock. 1 revolution all the way around is 360 degrees. Okay, so picture-wise, 1 revolution, you'd still start on the positive side of the x-axis. Counterclockwise, you're going against the clock, so all the way around would be a positive 360 degrees. If I go, and I will use REV for revolution, 1 revolution clockwise would be a negative 360 degrees. And it would be, still start on the positive side of the x-axis and you're going down. So this would be a negative 90, negative 180, negative 270, and all the way around here. So that'd be a negative 360 degrees. Okay? And we're going to end up doing most of this on the calculator but 1 degree, if you separate that, 1 degree is 60. Okay, look up here. This symbol stands for minutes. 1 degree, you can separate. Think about how small 1 degree is. Separate that into 60 parts in each part. Okay, so this is 1 degree equals 60 minutes. Okay, and then 1 minute equals, think how small 1 minute would be. 1 minute equals 60. Okay, and look at this symbol, 60 seconds. Okay, so 1 minute equals 60 seconds. Okay, now the author is going to have you convert from what we call decimal degrees to degrees, minutes, and seconds, and degrees, minutes, and seconds back to decimal degrees. And I'm going to take you through how to do that. We used to do all of this by hand. Okay, lucky for you, Texas Instruments and other companies put it all on the calculator. Okay, so let's look at examples. Express each angle using degrees, minutes, and seconds. Okay, now this one they're going to give you decimal degrees and they want you to go to degrees, minutes, and seconds. So let's say I give you 20.6 degrees, and that's the symbol for degrees. Okay, 20.6, and they want you to go to degrees, minutes, and seconds. Okay, so on your calculator, okay, go to the home screen and just put in 20 points. Oh, before we start, check your mode. Okay, and for what we're doing, okay, we're not doing anything with sine, cosine, tangent yet. So right now we're in radians, but that's not going to affect our answer, okay, because we're going to go to degrees, minutes, and seconds. Okay, so put in 20.6. Okay, right above the blue apps key, it's blue on mine, it says angle. Okay, everybody find that? Okay, so do second function angle. Okay, If you go down to number 4, you're going to see this, and you need to take enough notes so that, say, a year from now, 4 years from now, how did I do that on my calculator? Okay, number 1, we did second function, and if it's a key, I usually circle it. Second function angle, okay, but where was that? Okay, that was above the apps key, something so that you know where that's at. And then we go down to where it says degrees, minutes, and seconds. The DMS stands for degrees, minutes, and seconds. So that's number 4. Okay, if you press that, okay, and then press enter, okay, it will change to degrees, minutes, and seconds. So you got 20 degrees, 36 minutes, 0 seconds. If you did that by hand, if you went up and used the conversions up here, 0.6 of a degree, you would take 0.6 times 60, and that would give you the 36. Okay, that's how we used to do it by hand. Okay, let's look at another example. Say I have 47.59. That's called decimal degrees. Okay, so put in 47.59. Do second function angle right above the apps key. Just do number 4, degrees, minutes, and seconds, and that says that arrow is saying go to degrees, minutes, and seconds, and press enter. Okay, and you end up with 47 degrees, 35 minutes, 24 seconds. Everybody agree with that? Okay, let's do one more. Now, what if we have 5 degrees and 2.5 minutes? 0.5 minutes. What's 1 minute? How many seconds? 60. So 0.5? 30. Okay, so if we just did the 5.2 and go to second function angle, go to degrees, minutes, and seconds. Okay, we have 5 degrees, something's wrong on mine. Did you guys get that?
Yeah.
Okay. Something is not right there. Ooh. It's going to be 5. It's going to be, yeah, this is not right. Punching that in on the calculator is not right. So it's 5 degrees. They're already giving it to you in minutes, right? So it's 5 degrees, 2 minutes. How many seconds? 30. Okay? That one's a little bit different. Okay? Okay? Whoops. Okay, now we're going to go the other way. Okay? They're going to give it to you in degrees, minutes, and seconds. And then we're going to go to decimal degrees. Okay? So let's look at that one. Okay, express each angle in decimal degrees. Okay, express each angle in decimal degrees to the nearest. Now, don't miss these, and this is going to happen a bunch in Trig. You have to look at how they're asking you to round it. This one is to the nearest hundredth of a degree. So you're going to look at the third decimal place and then round it. Okay? Okay, so let's look at 10 degrees, 30 minutes, 15 seconds. And then we want to convert that to a decimal degree. Okay? So, to put that in, put in the 10. Then you still do second function angle. Okay, and you should see the first one up at the top. first one up at the top should be degrees. Okay. Then put in the 30. Second function angle. Okay, now look, the first one is degrees, the second one is minutes. Okay, but if you look at your list, there are no seconds in there. Okay, so pick up number 2. Okay, now put in the 15. Okay, now it took me a long time when I first started doing this. Right above the plus sign. You see it in green? That took me forever to figure out. I had to go look that one up. It's like, okay, I am not finding the seconds anywhere. Okay, it's right above the plus sign and it's a green, so that means it's an alpha key. So do the alpha key and then the seconds. Okay, then press enter. Okay, now on the rounding, okay, you look, they want it to the nearest hundredth. Okay, and if you look, the answer is like 10.504. Okay, you're going to look at the third place. If that's 5 or greater, you're going to round that up. Okay, it's not. So our final answer is 10.50, and the units are degrees. Okay, you can, and you're going to have to be careful as you come in here. If you borrow one of my calculators, classroom calculators, you've got to look at how it's set. Okay, go to the mode key. If somebody was working these problems and said, okay, I'm going to round these to the nearest hundredth, okay, so they could go in and go to the floating, change that and round it to a 2, okay, then when you go back, okay, it automatically rounds it. But if they don't change that calculator back to floating and you're working it, all your answers are going to have 2 decimal places. And you might think, oh, well, that's just the answer. No, not necessarily. Okay, so every time you use one of my calculators or even your own, you need to, how did I set it? Okay. Okay, let's look at another one. 27 degrees, 42 minutes, 58 seconds. Okay. Okay, so let's go 27, second function angle. Pick up the degree symbol. 42, second function angle. Pick up the minute symbol on number 2. Okay, and then 58, and then do the alpha, and the seconds is above the plus sign. Okay, now you end up with 27.716. Round it to the nearest hundredth. Okay, so it should round to 27.72, and that's in degrees. It would make a difference on this if they change this to round to the nearest tenth. Okay, so you need to be careful on the rounding. Okay, now I went through something on here on the calculator. I did not write it down. Did you write it down? Where are the seconds? Did you write that down in your notes? 4 years from now, are you going to have to search for that, figure out where's that seconds? Okay. Okay, so that's the first part of the assignment. Going from decimal degrees to degrees, minutes, and seconds. Degrees, minutes, and seconds. Back to decimal degrees. Okay, now put a little separator. Everything up to that point we were working in degrees. Okay, now the author is going to go through definition of radians. Okay, a radian is a unit of angular measure. And if you look on your calculator, even our calculator or just a regular TI scientific calculator, it'll have degrees, radians, and grads. Okay, we're not doing anything with grads. We're going to do everything with degrees and radians. But that is, grads is another unit of angular measure. Okay, and the measure, a radian is the measure of a central angle. Oh my gosh, there's your geometry coming back. A central angle. Okay. Remember what a central angle is? Central angle is where you've got an angle. The vertex is at the center of the circle. Okay. Remember, you had other angles like this. Okay. All that geometry is coming back. Okay. The one we're thinking of is the central angle. Okay. The measure of a central angle of a circle whose intercepted arc is equal to, okay, the measure of a central angle of a circle whose intercepted arc is equal to the length of the radius of the circle. Okay. It's the measure of a central angle of a circle whose intercepted arc, okay, is equal to the length of the radius of the circle. Okay, picture-wise, draw a circle. From the center out, label that R, the radius. If you take that same length for R and mark it along the arc of the circle, okay, if you would measure that, okay, if this was R, okay, as long as this length equals this arc, okay, then this angle theta is equal to 1 radian. Okay, theta is equal to 1 radian. Now, if I was saying the radius was 7 inches, and then if I measured the length of the arc 7 inches, then that angle mapped out 1 radian. And if I said it was, the radius was 500 miles and the length of the arc was 500 miles, okay, then that angle is equal to 1 radian. Okay. They will give you some problems like this. Say if I said this radius was 3, and I don't care what units, but they're going to be in the same units. And if I said I measured this arc, and the length of this arc here was 7. Okay? How many radians? What you do is you take the length of the arc divided by the radius, and you end up with 2 1/3 radians. Now, there's a formula for that, okay, and the formula is S. S is the length of the arc divided by the radius, and it equals theta, the angle, in radians. Now, normally in the book, it won't be written that way, okay? What they do is they write it S. If you looked at this as over 1 and cross multiply this, you're going to get S equals R times theta. This is the main formula, and it's actually, you need to somewhere put in there S stands for the length of the arc Okay, so this is the S. The R is the radius. Okay, and you'd want to have those in the same units, either if they're all in miles or if they're all in feet or they're all in inches. The kicker on this formula is theta has to be in radians. Theta has to be in radians. So when this, do a little note on this, it has to be in radians for this formula to work. If they give you 60 degrees, you cannot just put in 60 degrees. You'll get the wrong answer. Theta has to be in radians. So that means we've got to be able to convert from degrees to radians and radians to degrees, back and forth. Okay? Okay, so if we take a circle, okay, what's the distance around the outside of a circle called? Circumference. Okay? Now, go back in the memory banks. What's the formula for circumference of a circle? Not pi r squared. That's area. Pi times diameter. And if I ask you what is it in terms of radius? Yeah. Okay, so you can use this one, pi times the diameter, but if I want it in terms of the radius, it's like 2 pi r, okay? That's the formula for circumference of a circle. If we go back up to this formula up here, okay, for every circle, if I take the outside circumference would be 2 pi r and divide it by r, right? The r's divide out, and the angle would be equal to 2 pi. So all the way around once on a circle, in terms of radians, is 2 pi radians. Okay? Okay, so if you take the radius and divide those out, you're going to end up with 2 pi, and that is your theta. So 1 revolution all the way around is 2 pi radians. And sometimes the book will use a little r up above. When we get into this, anything in terms of pi is going to be in terms of radians. Okay, so you don't have to label that. And it's 360 degrees. So 1 revolution all the way around is 2 pi radians, or 360 degrees. Okay? So if I said convert 60 degrees to radians, 60 degrees is how many radians? Okay? If you figure, I always go back, and if you forget on the test or forget on the ACT or whatever, you can always go back and say, okay, 2 pi radians equals 360 degrees. I want to know what 1 degree is. Okay, so 1 degree divide by 360, that'll give you 1 degree. If you divide by 360 on that side, you got to divide by 360 on this side, and you can reduce. The 2's would divide out, and you'd end up with pi over 180 radians equals 1 degree. Okay, so if you take 60 degrees, but 1 degree is pi over 180, and you've got 60 of them, so multiply by pi over 180. These will divide out, reduce. 60 would go in there once, 60 would go in there 3 times. Multiply across on the top, you end up with pi. Multiply across on the bottom with 3. Okay, so you end up with 60 degrees is pi over 3, and that's in radians. Okay, pi over 3 radians. Okay, so the shortcut on this is, if you're going from degrees to radians, we started with degrees, we wanted to go to radians. Degrees to radians, you're going to multiply by pi over 180. Okay, multiply by pi over 180. Okay. Okay. Now let's go the other way. A little separator there. Okay. If I want to convert pi over 6, and that's in radians, to degrees, I still go back to the original 2 pi radians equals 360 degrees. What's 1 radian? Well, divide by 2 pi. So if you divide by 2 pi on both sides, those divide out, you get 1 radian. And if you reduce this, you get 180 over pi degrees. Okay, I've got pi over 6 radians. So pi over 6 radians, and I want to get to degrees. 1 radian is pi over 180. Excuse me, other way around. 180 over pi. Okay, so multiply by 180 over pi. Reduce it. The pi's would divide out. Those will reduce. Don't say they cancel. Canceling means subtraction. Say they either reduce or they divide out. 6 would divide out, and 6 would go into 180 30 times. Multiply across on top, multiply across on the bottom. So pi over 6 radians is equal to 30 degrees. Okay? So the shortcut, if you're going from radians, what's it now? If you're going from radians to degrees, we're still gonna multiply, but we're gonna multiply by 180 over pi. Okay, so still multiply, but multiply by 180 over pi. Okay. Now, if you look at the whole coordinate plane, let's look at the whole circle on a coordinate plane for a minute. Okay, we said, and I want to look at this in terms of radians. If you start here at the positive side, if we're looking at an angle right here, that's where the initial and the terminal side both lie on the positive side of the x-axis. That's 0 radians. If you go all the way around, if you would start here and go all the way around, what's 1 revolution all the way around? In terms of radians, what would it be? 2 pi. So all the way around would be 2 pi radians. Okay? If it's all the way around is 2 pi, okay, what is it to here? What's halfway around? 1 pi. So 1 pi is equal to how many degrees? Pi radians is equal to 180 degrees. Pi radians is equal to 180. If from here to here is pi, what's half of that? Pi over 2. So pi over 2 radians is actually 90 degrees. Okay? If I said take from here to here, what's half of that? What's half of pi over 2? Pi over 4. So pi over 4 radians is actually how many degrees? 45 degrees. Okay, let's go back the other way. If I go all the way to here was pi, this was pi over 2, this was pi, that's like 2 pi over 2. What's this? This is 1 pi over 2, 2 pi over 2, 3 pi over 2. So 3 pi over 2 is the same as 270 degrees. And 2 pi is the same as 4 pi over 2, right? 4 pi over 2 is 2 pi. That's all the way around. Okay, so you already know some of the radians just by looking at the picture, okay? But you can also use the conversions, okay? Now, they will give you some problems like this, and I'm going to show you 2 ways to do it. What quadrant is 4 pi over 5 in. When they ask what quadrant is it in, they're really asking where's the terminal side lie. Okay? Now, for sure, on this first part of the chapter and on the first test, do not miss any of these because they're in radians. You can always, always, always convert to degrees first. So let's do that first. Okay? So let's do it that way. If I took 4 pi over 5, okay, times, what am I going to have to multiply? 180 over pi. And reduce it. The pi's would divide out. 5, we've got to go 5 in there. What? 5 goes in there. 36. 36 times 4. 144. Yep, 144. Now, you're looking at this picture. You're starting here, still in standard position. 144. So what quadrant are you in? Quadrant 2. So that's your final answer. Quadrant 2. Now, that's doing it by converting it to degrees. Because right now, you probably don't know you're not familiar with it enough yet. So don't miss any of them. You can convert it to degrees. If I was doing this, okay, because my mind's thinking in radians, okay, and I'm going, that's too much work, okay? So what I would do is I would think of it this way. Okay, I'm looking at this fraction. 4 pi over 5. 5 pi over 5. 5 pi over 5 reduces to 1 pi. And I know 1 pi is okay, 1 pi is 180, right? So I'm just going to back that off a little bit up here, okay? And I know I'm in quadrant 2, okay? And I don't do a whole lot of calculations. But that's because I'm thinking in radians, okay? So either way, you get the answer. Let's do another one like that. If they said same directions, and that the angle they give you is 13 pi over 7, okay? Now, I can convert that. Take that times 180 over pi. Okay. The pi is reduced. 7 doesn't go in there evenly, does it? No. On your calculators, take 13 times 180 and then divide it by 7. What'd you get? What was it? That's good. 334. So what quadrant are you in? Quadrant 3. 4. 4. Quadrant 4. Okay, now, if this was me, I didn't want to do that much on the calculator. Okay, so I'm looking at this. Instead of looking at 13 pi over 7, I'm looking at 14 pi over 7. 14 pi over 7 is 2 pi. So, and 2 pi is all the way around. Okay, I'm a little short of that. So I'm in here, so I'm at quadrant 3. Or 4, sorry. Quadrant 4. Gosh dang it. Quadrant 4. Okay. But that's a little less, if you don't have the calculator. Okay. And that's when you start thinking in radians. But for a while, don't miss anything because it's in terms of radians. You can always convert it to degrees, and then you can convert it back, or you can look at your picture and go from there. Okay? Okay. That should get you started. Okay.